Welcome to clickmyproject.com. Our product title is a simple FPGA system for ECG RR interval detection. Now we are going to discuss about our product abstract. In our process we have implemented the ECG extraction using analyze and classification of the real-time has become the possibility. The main requirement of low power consumptions and low energy operations in order to have longer battery lifetime process, the ECG signal processing and the classification systems the process. The machine language of techniques, neural networks and support vector machines has been suggested and useful to improve the detection of the efficiency. Although these methods have advantages of in the detections of ventricular arrhythmia, there have been some shortcoming, some to the difficult to implement or compute. Some have the low specification of the normal and abnormal conditions, and all maintains the ECG for extraction for that PQORS. Now we go implement the RR intervals. So some specifically RR intervals come disease is occurred, and we detect the normal and abnormal and the how they detect the disease name of the process. So the detections interval which using the RR interval and of the action of, and then the approximately we get the data sets into in real time for normal and abnormal persons. The most ventricular arrhythmias are caused by the coordinate heart disease. The process the like classification and the process in the ECG, the detect analyzes the changes the characteristics of the ECG signals. So many times we propose the integrate of the low powered predictions of ventricular arrhythmia and on-site of the knowledge in the first solution of the SVM vector machines, the ECG segmentation of the feature and the extraction process. And the waveform of the ECG signals changes the without following the consistent patterns, so the detections is not enough to save life the patients. So we detect the ECG, the DSP basic concept, and very particularly we classification using the SVM classifier, the digital signal processing unit, the high pause sigma delta modulate based on the biosignal processing. Now we are going to discuss about our product flow diagram. In our process we have first ECG get the signal from data set, and to filter the input ECG signals using the MATLAB 2013 software, and to apply the low pass filters and to pass the MATLAB into silings. So first we couldn't get the file directly for silings, so we are going to the MATLAB coding how we create the signals and to text the convert the text. So we are using the MATLAB 2013, and then we go into the DFT based QRS detection feature extraction architecture, and then many we are using the signal processor. So we use filter some noise. So we are using the Gaussian kernel unit, the approximate multiplier, the structure of the process, and go into the cardiac based P elements architectures. The processing elements we some give the input signals, and the based on the what we create the threshold value for the ECG signals or normal and abnormal persons values. So we create the some processing element architectures, and then we go into the scaling unit functions level. This process we get the data set support vector processing, all pre-processing work in the support vector machines, and to set the method of the threshold values as yes and no conditions, and match and mismatch conditions, so normal or abnormal process in the level. So using these scaling factors using the silings process, finally the matching the result overall ECG database set samples, we get the lot of ECG signals. Now from method for get normal and abnormal. Abnormal is we conduct the arrhythmia, tachycardia, bradycardia. So some variation of disease we calculate and to display the LCD displays, and then waveform displays. So finally we get the last waveform from using the how we disease the head get the values, how percentage of the values, so creating the flow of the process. Now we are going to discuss about our product running procedure. So we have our implementation having the two tool of that. One is the MATLAB and another one is the silings code. First of all we go into the MATLAB coding running. How we get the input the file, I would read the signal. After go into the convert the text file. So this is the folder for the main source code of our process. Just copy this path folders and go into the opening the MATLAB 2013 A versions, paste the directory of the coding, and then main function having that MATLAB coding. This coding have description that have input file the reading. After only the input ECG signals with a noise and ECG signals without noise, we separate the plot the graph model. Just run the process. So did get the data set. We have in the data set for the 10 data sets for normal, abnormal, and abnormal the process. Just we choose one data set for signals. So we plot that easy signals with noise and without noise, and automatically open the silence process. So silence we just simulate that how we using the assume classifiers, and that interval based on the ECG QRS direction feature extractions. So we so many for that coding is implemented. That just we go into the simulation process after the coding and simulate behavioral model. We just run this process. After we automatically open the iSim simulator. The simulator we give the some inputs for that is clock, enable the functions, automatically generate the output signals of the we just display and represent the text file or characteristics. So what we have in the normal or abnormal, whatever it's displayed this process. Just we give the process clock, force clock. So leading edge value is 0 and trailing edge value is 1. The periods is 1000, ns nanoseconds. So apply and OK. We just run the process. We get the output for result the text file some whatever. So what have the these signals having the purpose, we just display this process. The output we got it, the output ECG status for the tachycardia is one of the abnormal disease values. Okay, ventricular aura intervals. Okay, thank you watching our video.